दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्.
Now, dear students, we will be starting another new topic, that is carbonyl compounds. In our syllabus, we have what are carbonyl compounds, then nomenclature of types of carbonyl compounds, nomenclature of carbonyl compounds, isomerism exhibited by the carbonyl compounds, preparation and properties of aldehydes and ketones, then properties of aldehyde and ketone. This is a very big chapter and a very important chapter, and if a student is very clear about alcohol, aldehyde, ketone, then carboxylic acids and other topics will not be difficult for you. Now if you read perfectly well the alcohol, then come to study aldehyde, ketone, you will feel as if you have done 30 to 40% of its chemistry in alcohol chapter. I have explained very perfectly in alcohol chapter most of the reactions involved in aldehyde and ketone. Now we will come to chemistry of carbonyl compounds. In the next topic we are going to study the carbonyl compounds. The compounds, the organic compounds with a carbonyl group, are called as carbonyl compounds. Carbonyl compounds. Then what is the carbonyl group? Carbonyl group, when the carbon atom is in sp2 hybrid state, bonded to oxygen covalently by forming a sigma and a pi bond, is called carbonyl group. Because why I am telling this, for a student of board exam, what is a carbonyl group may be a question to you. What is a carbonyl group may be a question to you. When the carbon atom in the sp2 hybrid state bonded to an oxygen atom which is also in the sp2 hybrid state by a sigma and a pi bond, the group is called a carbonyl group. It is called carbonyl group, and compounds containing carbonyl group are called as carbonyl compounds. What I told you? I told you that this is a carbon atom and this is bonded to oxygen by a sigma bond and a pi bond simultaneously, and this oxygen atom is in the sp2 hybrid state, this oxygen atom is in the sp2 hybrid state. Means it is a coplanar molecule. The compounds containing all carbonyl compounds are coplanar molecules, and this oxygen atom has two unshared pair of electrons. This group is called as carbonyl group. When the carbon atom is bonded to oxygen by a sigma and a pi bond, in which both carbon and oxygen are in a sp2 hybrid state, is called carbonyl group. And compounds containing carbonyl group are called as carbonyl compounds. That means these are the two bonds. You will satisfy these two bonds by hydrogen atom and alkyl group, or by two alkyl groups. We can satisfy the two valencies of carbon by a hydrogen atom and a alkyl group. So now let's come to this. Before going to that, I will tell you what is this carbonyl group. Now if you come to the carbonyl group, in the carbonyl group, the carbon atom and oxygen atom, this, what is a pi bond? Pi bond is a loosely held electron cloud, more diffused into the space. Is a loosely held electron cloud, means it just oscillates between carbon atom and oxygen. Oscillating means if one tries to pull, one can pull that pi electron cloud. Oscillating between carbon and oxygen, and loosely held electron cloud, more diffused into the space, just like a screen in a room tied by two springs. It is like this. So the electronegativity of oxygen is 3.5 and carbon is 2.5. Carbon is 2.5, oxygen is 3.5, and atomic size of oxygen is much smaller than the oxygen atomic size of carbon. Hence, this oxygen atom has always a tendency to attract the electron cloud. So this electron cloud, the electron cloud of sigma bond is also going towards oxygen, and this goes towards oxygen by electromeric effect. So another possibility for the carbonyl group, we get carbon atom, this is oxygen atom, and the electron pair forming the pi electron cloud came to oxygen, hence negative charge, and there is a positive charge, and this exhibits. Now the carbonyl group is represented by two structural forms. There is a non-ionic structure and there is a ionic structure. Due to the delocalization of pi electron, we get a second structure, or structure B for carbonyl group, structure A for the carbonyl group. So that means carbonyl group has the ability to exhibit resonance. So these are the two resonating structures of carbonyl group. So one is a non-ionic structure and the other is a ionic structure. So we can write the resonance hybrid of the carbonyl group as like this: carbon atom, oxygen atom by a sigma and a pi bond, and there is a drift of electron take place towards oxygen. Oxygen gets delta negative charge, so this delta positive charge, so this is the dipolar. So the carbonyl group is a dipolar. This is the resonance hybrid of the carbonyl group. This is the resonance hybrid of the carbonyl group and is dipolar. So carbonyl group exists in a dipolar state. So those molecules which containing carbonyl group, it will induce dipolar character into those molecules. So those molecules will be definitely very reactive, because in the molecule there will be a positive charge center and negative charge center. So there is a positive charge center, there definitely the negative will be attracted toward this. Nucleophiles will be attracted toward this. The carbon atom will attract the nucleophile, and when the nucleophile will come, it will break the pi bond. So these compounds will undergo nucleophilic addition reaction. And oxygen atom has a negative charge. So if two hydrogen atoms will come, they can take out this oxygen atom from the molecule. So this is a reactive. Those molecules, those compounds which contain carbonyl group, they are very reactive. So the dipole moment of this carbonyl compounds generally, it has a strong dipole moment. All the carbonyl compounds, they have a strong dipole moment. The symbol for dipole moment mu comes around 2.3 to 2.8 dBi. The symbol for dipole moment, the unit for dipole moment is dBi, and they have a very strong dipole moment, 2.3 to 2.8. Almost all carbonyl compounds have a very strong dipole moment, 2.3 to 2.8. So they are very reactive molecules. They are very reactive molecules. So all carbonyl compounds are very reactive state. And there is a polarization of the pi bond takes place always in the carbonyl group. So this carbonyl group induces reactivity to carbonyl compounds. Those compounds is containing carbonyl group, they are always reactive. So this is what is carbonyl group. Now we'll come to what are carbonyl compounds. The compounds containing carbonyl group are called as carbonyl compounds. The compounds containing the carbonyl group are called as carbonyl compounds. So a question, a student of class 12 has a question, what are carbonyl compounds? What are carbonyl compounds? So those organic compounds which contain a carbonyl group are called as carbonyl compounds. How they get? So this is the carbonyl group. We have the carbon atom bonded to oxygen by a sigma and a pi bond, and when this is a carbonyl group. Now this, if we can satisfy the one by a hydrogen atom and one by a hydrogen atom, one by a alkyl group. So when the one of the bond of the carbonyl carbon is satisfied by a alkyl group and hydrogen, this is called aldehyde. This is called aldehyde. Why? Now this CHO group is a functional group. This group is called aldehydes. And when the two bonds of the carbon are bond satisfied by two alkyl groups, we get a compound CO, and these are two alkyl groups, so these are called as ketone. So the carbonyl compounds are of two types, aldehyde and ketone. When the carbonyl group is bonded to a hydrogen atom and an alkyl group, it is called aldehyde, and CHO group is the aldehyde group. And when the carbonyl group is bonded to two alkyl groups, it is called ketone. Here the carbonyl group is called ketonic group. Here this group is called aldehyde group. Here the carbonyl group is a ketonic group. Now we can satisfy the two bonds by two hydrogen atoms also. This is also an aldehyde. This is also an aldehyde. So this aldehyde is called as formaldehyde because this is an aldehyde of formic acid. So this is called formaldehyde. So what are carbonyl compounds? When the compounds containing carbonyl group are called as carbonyl compounds when the two valencies of the carbon atom are satisfied by a alkyl group and a hydrogen atom, it is called aldehyde. When the two valencies of the carbon atom are satisfied by two alkyl group, it is called ketone. So the two types of carbonyl compounds are aldehydes and ketones are the carbonyl compounds. Now we'll come to the all organic. So what is the theme of organic compounds? All organic compounds are derivatives of hydrocarbon. All organic compounds are derivatives of hydrocarbon. If you take RH as the aldehyde, and if from the aldehyde it has alkane has general molecular formula CnH2n+2. If we remove the hydrogen atom and attach a aldehyde group to that, we get RCOH. So this is an aldehyde. This is an aldehyde. So this is a carbonyl group with hydrogen atom is called aldehyde group, and this is called aldehyde. What is the general molecular formula? CnH2n+2. So this will be CnH2n+1 CHO. We can write, or you can add H here and carbon here. We can write also CnH2nO. The aldehydes have general molecular formula CnH2n+1 CHO or CnH2nO, aldehyde. Now when you take the alkene RH and we remove the hydrogen atom by a keto group COR, ketonic group, we get RCOR. This has also molecular formula CnH2nO. So the aldehydes have, both aldehydes and ketones have general molecular formula CnH2nO. So they were removing hydrogen atom and attaching COR. So this also has molecular formula CnH2nO, and aldehydes also have the molecular formula this. So there are two types of carbonyl compounds, are aldehyde and ketones. If I put everything at one place in a schematic manner, so this is a carbonyl compound. So the carbonyl compounds are of two types. Carbonyl compounds are of two types. There may be aldehyde, where the functional group is COH is the functional group, and have general molecular formula RCOH. It is as CnH2n plus 1 CHO or CnH2nO. And the other is a ketone, where you have the ketone, you have the ketonic group is the ketonic group COR, and they have the formula as RCOR, and they have the molecular formula as CnH2nO. Now these ketones can be when that both the alkyl groups are symmetrical. So these ketones are of two types. Ketones can be of two types: symmetrical ketone and unsymmetrical ketone. Ketones can be of two types: symmetrical ketone and unsymmetrical ketone. When the two alkyl groups are identical, when both the alkyl groups are identical, when two alkyl groups are identical, it is called symmetrical ketone RCO. And when alkyl groups are different, we'll get R-CO. You can write RRCO, or you can write this also very easy. You can write RRCO, symmetrical ketone, and RCO, R- unsymmetrical ketone. Is called symmetrical ketone, and this is called unsymmetrical ketone. So aldehydes and ketones, these are the carbonyl compounds. Now we'll go to nomenclature of aldehydes and ketones. How the aldehydes are named and how the ketones are named. Both aldehydes and ketones are named by the two system by the common name and IPEC name. Now we'll come to nomenclature of carbonyl compounds. So both the names they have IPEC name. Now let's first come to the nomenclature of aldehyde. We'll come to IPEC name. IPEC name. So this is RH, and alkane. From RH we are removing H and putting COH, aldehyde group. The aldehyde group, its name, its symbol is Al. Aldehyde symbol is Al. So this comes as RCOH. So this is alkane, and from alkane we are removing hydrogen. Removing hydrogen means we are removing E. In nomenclature, when we remove hydrogen, it is minus E. And what we have done, we have included alkyl group, so alkanal. So aldehydes are called as alkanal. Al stands for aldehyde, OL stands for alcohol, alkanal. The aldehydes have general molecular formula CnH2n plus 1 CHO or CnH2nO, and IPEC name is alkanal. Now we'll come to the what is the common name of aldehyde. Common name of aldehyde. What is a common name? The common name is a name given to an organic compound depending on its origin or occurrence or peculiar property it exhibits. So the common name, the aldehydes are considered as reduced product of carboxylic acid. The aldehydes are considered as reduced product of carboxylic acid. How? This is RCOH, There is the carboxylic acid. Carboxylic acid. From the carboxylic acid, if we remove O, we remove this O, then what you got? You get RCOH. So, aldehyde. An aldehyde is a reduced product of the carboxylic acid. Hence, aldehydes are named after the carboxylic acid of which they are the reduced product. Very simple. Very simple. The aldehydes are named after the carboxylic acid of which they are the reduced product. So then how the name is given? So name of carboxylic acid, we take the name of carboxylic acid. Now it was carboxylic acid, it is no more acid, so minus IC acid, because there is no more acid. Now we will come to the common name of the aldehydes. So aldehydes are considered as a reduced product of carboxylic acid. If you compare the molecular formula RCOH and RCOH, so you remove O, you get aldehyde. So an aldehyde is considered as reduced product of carboxylic acid. So an aldehyde is named after the carboxylic acid of which it is a reduced product. So name of the carboxylic acid minus IC acid plus aldehyde. Plus aldehyde. That will give you the name. So many often this doubt is there, children. Now aldehyde is called aldehyde. No. An aldehyde is a reduced product of carboxylic acid, hence named after the carboxylic acid of which it is a reduced derivative. Now let's come, if we take the formula RCN+H2N plus 1 OH. What is the molecular formula? CN molecular formula is CN+H2N plus 1 CHO. So now if N is equal to 0 you put. So what you get? We get HCOH. This is aldehyde. This is aldehyde. Then what is its acid? Its acid is what? HCOH. This is called formic acid. This is called formic acid. From formic acid we are removing O, we get HCOH. So formic acid minus IC acid plus aldehyde. This is called formaldehyde. This is called formaldehyde. Many often if why formaldehyde is called formaldehyde? The students give the answer because it is formaldehyde. No, it is an aldehyde of formic acid. It is an aldehyde of formic acid. So formaldehyde. Similarly, when you come to CH3COOH, this is acetic acid. This is acetic acid. From acetic acid we remove H, we remove O. When we remove O, we get CH3COH. So minus IC acid plus aldehyde is called acetaldehyde. Is called acetaldehyde. So acetaldehyde is a reduced product of acetic acid. Hence it is called acetaldehyde. So this is the way, what are the common name. Now we'll come to the nomenclature of the ketones, how the ketones are named. So the ketones are named by the same way as the common name and IPEC name. Ketones, nomenclature of, we are going to ketones. So if you come to first IPEC name. So here the suffix is used ketone, ONE. They take the ONE is the ketone, they have taken the ONE. So the ONE is used as the suffix. ONE is used as a suffix. So this is RH is alkane. From RH we are removing H, putting COR, we get RCOH. So this is alkane. Hydrogen is removed. So minus E, we remove hydrogen, minus E. Then what you have done? We attach COR. What is COR? Is ONE. So we put ONE. So this is called as alkanone. So ketones are called as alkanone. Ketones are called as alkanone. The IUPAC name is alkanone. So a ketone must have to have at least 3 carbon atoms. You cannot have a ketone containing 2 carbon atoms. A ketone has to have at least 3 carbon atoms. 3 carbon atoms. Now common name. Common name is ketone. The common name is ketone. Now this ketone, we have 2 types. The ketones are of 2 types. One is called symmetrical ketone and unsymmetrical ketone. In symmetrical ketone, we have RRCO. We can have RCOR. Both alkyl groups are similar. So dialkyl ketone. It's called what? Dialkyl ketone. The ketones are similar. Dialkyl ketone. And both the alkyl groups may be different. RCOR. So we have 2 alkyl groups. One is R and that is R dash. So here they are named after the alkyl group. Unsymmetrical ketone, they are named after the alkyl group. How? Now by the alkyl group, they are named after by the ketone, they are named after by the alkyl group. How? By alphabetical order. This is ether we have done in nomenclature. In ether, the same thing. Here also, same thing. Unsymmetrical ketone, the alkyl groups are named after the alkyl groups in alphabetical order. So let us take an example. CS3, CO, CS3. The first simplest ketone is CS3, CS3. So we will write its common name and write the both IUPAC name of ketones. So we will write the common name and IUPAC name. IUPAC name is very simple. It is alkanone. Alkanone. And common name is ketone. So this is called as a dimethyl ketone. 2 methyl groups are there. It is dimethyl ketone or it is called acetone. Children, there is a question to you. Why it is called acetone? Dimethyl ketone, CH3, 2 methyl groups, dimethyl ketone. Alright, why just you think why it is called acetone? You just a question I am giving you, you think. I will come and I will tell you the answer, whether my answer sits to you or not. And what will this? Its IUPAC name is propanone. IUPAC name is what? Propanone. Why? 3 carbon atoms are there, derivative of propane, and there is propane minus E plus ONE, propanone. Now we'll come to CS3, CO, C2H5. So common name. What is this? Ethyl. This group is ethyl. This group is methyl. Ethyl comes first, alphabetical order. Methyl comes next. So this is ethyl methyl ketone. Ethyl methyl ketone. But when you come to the IUPAC name, we take longest chain, lowest number. So the longest chain is 1, 2, 3, 4. How many carbon atoms are there? 4 carbon atoms. Derivative of butane. At a 2 carbon atom, the keto group. So 2 ONE. So it was the butane. The name will be what? It was butane. 4 carbon atoms are there. It was butane. So hydrogen gone, minus E. Then what has happened? ONE is attached. Where the ONE is attached? At second carbon atom. ONE is attached where? At second carbon atom. So butane at second carbon atom 2 ONE is attached. So butan, the name comes as butan 2 ONE. Butan 2 ONE. not 2-butanone. It is a butanone. It is butanone. It is butanone. But at 2 so what is the hyphen meaning? Meaning, I told you hyphen in nomenclature, hyphen means is attached with. The meaning of the hyphen is attached with. That means second carbon atom is attached with a keto group. So these how they are named as a symmetrical ketone. So these are symmetrical ketone, these are unsymmetrical ketone. Now next class we will be discussing about the isomerism exhibited by the organic these aldehydes and ketones. The carbonyl compounds exhibit structural isomerism, that is CPFMR, chain isomerism, position isomerism, functional isomerism, then metamerism, tautomerism, and ring chain isomerism. So they exhibit the structural isomerism. Then what are the types of structural isomerism the aldehydes and ketones exhibit? We will discuss in our next class. Thank you very much for you attending this class.